Welcome to class, student. Today, we'll be looking at a very important topic titled ergonomic hazards. Ergonomic hazard represents workplace physical factors that pose risks to human health, particularly affecting musculoskeletal system. This hazard emerge from various workplace conditions and can result in significant health complications when exposure is prolonged or intense. Understanding ergonomic hazards. Ergonomic hazard manifests as physical condition or workplace arrangement that place stress on the body. They primarily target the musculoskeletal system, comprising muscles, tendons, ligaments, nerves, and supporting structure like the spinal disc. Common examples of ergonomic hazards include the awkward postures, repetitive movement, excessive force application, vibration exposure, and inadequate workstation configuration. Awkward postures, repetitive movement, excessive force application, vibration exposure, inadequate workstation configuration. Understanding ergonomic hazard. The awkward postures, working condition that deviate from neutral alignment, forcing joint into extreme angles. Repetitive movement is tasks requiring the same motion patterns performing continuously. Excessive force application, activity demanding significant muscular effort beyond comfortable capacity. Vibration exposure, regular contact with vibrating tools or equipment that transfers energy into body tissues. Inadequate workstation configuration, poorly designed work areas that fail to accommodate human dimensions and movement patterns. Extended exposure to these factors frequently leads to musculoskeletal disorders (MCDs), including carpal tunnel syndrome, tendinitis, lower back injuries, and various repetitive strain injuries. The human-machine relationship. Ergonomic design recognizes the distinct advantages and limitations inherent in both humans and machines. Human capabilities and limitations: superior adaptability to unexpected situations, advanced communication abilities, creating problem-solving capacity, physical endurance constraints, susceptibility to fatigue and error, variable performance under stress, machine capability and limitation, consistent performance without fatigue, superior computational speed and accuracy, greater physical strength and precision, limited self-maintenance abilities, restricted adaptability to novel situations, predetermined functional parameters. Benefits of ergonomic implementation and organization. Organization implementing ergonomic principles typically experience enhanced operational efficiency through streamlined workforce, significant reduction in workplace accidents and injuries, decreased training requirements, learning curves, lower operational costs through reduced absenteeism and workers' compensation claim, more effective utilization of human resources and capability. So the best benefit of including of implementing ergonomic in an organization is enhanced operational efficiency through streamlined work flows, that the work is enhanced, and there is smooth flow of work activity. There's significant reduction in workplace incidents such as the accidents and injuries. Then there's decreased training requirements and learning curves. There's also lower operational costs through reduced absenteeism and workers' compensation claims. There's more effective utilization of human resources and capabilities. Role of ergonomics. The core objective of ergonomics is creating work systems calibrated to human capacities and limitations. This approach simultaneously protects worker health while maximizing efficiency and well-being. Sustainable high-performance workplaces emerge when systems are deliberately designed around anthropometric measurements and biomechanical principles that respect human physical and cognitive parameters. By addressing ergonomic hazard through thoughtful design and implementation of human factors principles, organization create environment that supports both productivity and worker health, ultimately achieving superior operational outcomes through human-centered design. The mitigation strategies for ergonomic hazard. Exam Examples are mechanization of high-risk tasks, comprehensive ergonomic design improvement, organizational restructuring of work processes, enhanced worker training program. So these are the mitigation strategies for ergonomic hazard, the way of reducing hazard caused by ergonomic. Number one is mechanization of high-risk tasks. Like there are some tasks that are taxing, and it can be mitigated by using machine of implementation of machine or usage of machine. Then another is comprehensive ergonomic design improvement. Then another is organization, restructuring of work processes and enhance workers training program by training the workers on how to carry out the work effectively. It will help in mitigation of ergonomic hazards. Principles of biomechanics. We have the task variables, we have the human variables, and we have the environmental variables. Task variables, human variables, and the environmental variables. Task variables. In task variables, we have object, location, and dimensional properties, vertical displacement parameters, that is origin and destination height, lifting frequency requirements, object mass characteristic, worker positional constraints during task execution. We have human variables, demographic factors, sex, age, training level and procedural knowledge, physical conditioning status, anthropometric measurement and proportions. The environmental variables, looking at thermal condition, both excessive heat and or cold exposure, atmospheric moisture content, presence of airborne contaminants. Effect of non-ergonomic working condition. We have the tenosynovitis, bursitis, carpal tunnel syndrome, Raynaud's syndrome, back injuries, and muscle strain. These are the effects of non-ergonomic working. This tenosynovitis inflammation of tendon sheath, typically in the wrist and hand, resulting from repetitive movement or mechanical irritation. So it is an inflammation of the tendon sheath, which can be the wrist and hand. resulting from repetitive movement or mechanical irritation while walking. Then bursitis, that is inflammation of fluid feed sacs that cushion muscle, tendons and bone near joint. Then another is carpal tunnel syndrome. It's compression of median nerve as it travels through the wrist, causing numbness, tingling and weakness in the hand. Then we have the Raynaud syndrome, white fingers, episodic vasospasm causing reduced blood flow to fingers, often triggered by vibration exposure. Then another is back injuries, various spinal disorders including disc herniation, vertebral compression and muscular strain. Another is muscle strain, overstretching or tearing of muscle fibers due to excessive force application or awkward postures. So how to prevent ergonomic as a workstation setup: adjust your chair height to fit rest, so that feet can rest on floor with knees. I'll take that again. Adjust your chair height so feet rest flat on the floor with knees at 90-degree and angles. Position monitor at eye level and arms length away. Use chair with good lumbar support. Then proper techniques: practice neutral posture, that is stretch wrist and relax shoulder. Avoid prolonged static posture by changing position regularly. Movement and rest: take short breaks every 30 to 60 minutes. Incorporate stretching exercise throughout your work day. Alternate between sitting and standing if possible. Then training and awareness: learn proper lifting techniques, bend knees not waist, recognize early warning signs of strain, discomfort, numbness and tingling. Report issues promptly to address them before they are worsened. Thank you for listening.